So I want to look at a couple of different representations of calculations, and one is using a precise number line, and then we're going to talk about a flexible number line. So using a precise number line, I might look at this calculation of 5 plus 3 times 7 as saying, well, I'm going to start at the 5, and then I'm going to add 3 copies of 7. You could also add 7 copies of 3, but either way. So there's 1 copy of 7, and then here's another 7, and here is another 7. So 5 plus 7 gives me 12, plus another 7 gives me 19, plus another 7 gives me 26. So we see 5 plus 3 times 7 is 26. Now on a flexible number line, I'm going to do exactly the same picture, but I'm not going to necessarily care. I'm not going to worry about making sure that I have this precision. Whereas in this precise number line, I'm using the grid in order to make sure that I actually represent each distance accurately. So flexible number line is a way to get the idea of the calculation without necessarily needing the precision. So I might do this by saying, well, here's 0, somewhere up here is a 5, and I add 7 and 7 and 7. So I can look at this and say this is plus 21, so that gets me up to 26. Okay, so like I said, it's a tool for getting a general picture of the idea of the calculation without necessarily needing it to be precise. And one thing that allows us to do is also to introduce some variables. In this case, I put a 0 here, but I didn't necessarily need that 0 in there. But I can also do something like maybe I go, well, what is x plus 3 times 7 look like? Well, wherever x is, I don't know where this x is on the number line. This is where I'm not going to put a 0. But x plus 3 times 7 is the same. It's like adding 3 copies of 7 to x. So this is going to be x plus 3 times 7. And maybe I'm going to use this to try, what if x plus 3 times 7 is equal to 54? So that says I start with an x, I add 3 copies of 7, and I end up at 54. Well, this picture helps tell me something. This is the same as what number do I take and add 21 to get 54? And I can think about this and say, well, in order to figure out what x is, I take 54 and I go backwards by 21. And that means this should be 33. So that tells me 33 plus 3 times 7 equals 54. Let's just do a couple more. So what if we were to try something like 14 plus p equals 58? So the picture might be, start with 14, and I go forward some amount, and I end up at 58. And the question is, how much do I go forward? So one way to think about this, I don't know, if I go forward 10, that's 24, 34, 44, 54, that would get me to 54, and then plus 4 more. So would get me to 58. So 14 plus 44 equals 58. That tells me p equals 44. Let's do one more example. Let's get that number line out there. And I'm going to do y minus 84 equals 29. So I start with some big number y, and I subtract 84, and I get to 29. So to find out what this y value is, it looks like I must have to go forward by 84 units. So again, I might be able to think about this and go, well, if I go forward by 80, that gets me to 109, and then go forward one more, y must equal 113. So the idea of this is just to give you a mental picture to connect you to the meaning of the calculations without necessarily having to be precise. Like here, I did these pictures of plus 10s, but these are definitely not precise pictures, right? These are not precise measurements. It's just to give me a little bit of a picture to connect me to the meaning.